Hey everyone, in this video we'll learn how to find the average rate of change of any function. So let's go ahead and just start with the function. Let's say we had f of x equals 5x plus 20, for example. So that's our f of x, and let's say we wanted to find the average rate of change for this function between the x values f of 2 and f of 5. So between these x values, f of 2 and f of 5, we want to find the average rate of change. So first, let's write down the formula for the average rate of change. So the average rate of change, the formula is the change in output divided by the change in input. So this triangle right here, this is actually the Greek letter delta, and it's used to represent change. So it's the symbol for change in mathematics. Delta output over delta input. That just means the change in output divided by the change in input. So that's what that means. Now, what is the output and what is the input? Well, the output of a function is f of x, and the input of the function is x. We input x, and we get out f of x. So in the context of a function, the formula for the average rate of change, if we have two x values, so if we have x1 and we're also given x2, the average rate of change would be f of x2 minus f of x1 divided by x2 minus x1. So this is the formula for the average rate of change of a function between two x values, x1 and x2. So let's just go ahead and first evaluate these functions. So let's go ahead and find f of 2 and f of 5. So what is f of 2? Well, 5x plus 20, this is just 5 times 2 plus 20. And we can go evaluate this using order of operations, PEMDAS, so 5 times 2 is 10, and then 10 plus 20 is 30. So 30. And same thing here, this is 5 times 5 plus 20. Let's just go ahead and get rid of this. So same thing here, 5 times 5 is 25, 25 plus 20 is 45. Okay, and then now we can use this formula to find the average rate of change. So f of x2 minus f of x1 divided by x2 minus x1. So what are x2 and x1? So let's just go ahead and assign these. We'll go ahead and make 2 our x1, so x1 will be 2. And we will make 5 our x2. So our x2 will be 5. There we go. So now we can go ahead and evaluate this, or find the average rate of change between 2 and 5 for f of x. So what's f of x2 right here? F of x2 is just f. So, and what is x2? That's 5. This is just f of 5 minus f of x1. We said x1 was 2. So this is just f of 2 divided by x2 minus x1. So x2 is 5 minus, and then x1 is 2. There we go. Now what are f1, what is f of 5 and f of 2? Well, we said f of 5 was this one right here, 45. And we said f of 2 was 30. So this, the numerator comes out to 45 minus 30. So this is just 45 minus 30 divided by, and what's 5 minus 2 in the denominator? That's 3. And let's go keep evaluating this. 45 minus 30 is 15. So 15 divided by 3. And to simplify this, 15 divided by 3 is 5. And there we go. So the average rate of change of our function f of x is 5. That means on average, for each input in x, or every time x gets larger by 1, f of x gets larger by 5. So that's how you interpret the average rate of change. So on average, every time x goes up by 1, so if x increases by 1, on average, f of x will increase by 5. So using this, we can already guess f of 6, because we know f of 5 is 45, right? And we increased x by 1. We went from 5 to 6. So we increased x by 1. So for every increase in 1 in the x value, the average rate of change is 5. So 45 plus 5 equals 50. And f of 6 actually is 50. So that's what the average rate of change of a function is supposed to represent. And in fact, for this function f of x, the rate of change, no matter where the x values are, it will always be 5. The rate of change for this function will always be 5. So let's go through another example where the rate of change actually changes depending on where you are. So let's say we had another example, f of x equals x squared, and we were asked to find the average rate of change between the values 1 and 2. So in other words, our x1, so let's write it over here, our x1 is 1, and our x2 is 2. So again, our average rate of change formula is f of x2 minus f of x1 divided by x2 minus x1. So what's f of x2? So we know x2 is 2, so this is f of 2 minus, and then f of x1, we know x1 is 1, so f of 1 over x2 minus x1, so 2 minus 1. And what are f of 2 and f of 1? So if we go ahead and evaluate it in this function right here, let's just move this. F of 2 equals 2 squared, because f of x is x squared, so f of 2 is 2 squared. So f of 2 is 4. And then f of 1 equals 1 squared, which is 1. There we go. So f of 2 is 4, and f of 1 is 1. So f of 2 right here is 4, and then minus f of 1 is 1, divided by 2 minus 1. So evaluating this, what's 4 minus 1? That's 3. And what's 2 minus 1? That's 1. So 3 over 1, which is simply 3. 3 over 1 is just 3. So the average rate of change for f of x right here, f of x equals x squared, the average rate of change between 1 and 2 is 3. Now, it's the average rate of change, but it's not the average rate of change for every spot or for every input for this function. And what I mean by that is, let's pick different x values. So let's go ahead and actually pick 5 and 10. And let's go ahead and evaluate that. So let's just get rid of this. And just keep in mind, between 1 and 2, our average rate of change was 3. But between 5 and 10, you'll see that the average rate of change will be different. So between 5 and 10, let's go ahead and find that. What is f of 5 and what is f of 10? So f of 5 is 5 squared, which is 25. And f of 10 is 10 squared, which is 100. So f of x2, so this is just f of 10 minus f of 5 over 10 minus 5. And then evaluating this, f of 10 we said is 100. So 100 minus, And f of 5 we said is 25, so 100 minus 25 over, and what's 10 minus 5? That's 5, equals 100 minus 25 is 75, so 75 divided by 5. 75 divided by 5 is actually 15. So our average rate of change here is now 15. For the same function, we have a different average rate of change depending on which inputs we're looking at. We were looking before between 1 and 2, and the average rate of change there was 3. But now that we're looking between 5 and 10, the average rate of change here is 15. So for this function, f of x equals x squared, the average rate of change changes. Unlike the first function, where f of x equals 5x plus 2, in a linear function, the average rate of change is always the slope. So it's always going to be 5. And that's how we found 5 right here. So that's we found 5 to be the average rate of change, which is the slope of that linear function. But this quadratic doesn't have a slope. So the average rate of change for this quadratic function, f of x equals x squared, it's always changing. So let's go ahead and just check it out on a graph. Let's check out the quadratic on a graph. So we will go ahead and draw our axes right here. It goes 1, 2, 3, 4. -1, -2, -3, -4, -5. And then up here is 1, 2, 3, 4. And then down here is -1, -2, -3. And then -4. Okay, so let's go ahead and graph this function, f of x equals x squared. So we know how to graph this. This is just the standard parabola. So 1, 1, 2, 4, 0, 0, -1, 1, -2, 4. Okay, let's try that again. There we go. So that's our parabola. F of x equals x squared. Now the average rate of change between 1 and 2, as we saw, it was 3. So that means if we drew a line here, let's try that again. If we drew a line here between 1 and 2, the slope of this line would be 3. But in the higher values, because as you can see, x squared, it gets steeper and steeper as you go up. In fact, right over here at x equals 0, it's completely flat. It's completely flat over here. Over here, it gets a little more steep. Over here, it gets steeper. It gets steeper. And it gets very steep as you get closer, as x increases. And same thing on the other side. It's flat at 0, and between 0 and -1, it gets a little steeper. At -1, it's more steep. At -2, it's very steep, and beyond, it gets very steep. If you look at the lines, if you draw lines tangent to this function. So that shows you that the average rate of change, it changes depending on where you are on this function. And it's very important to understand that. So I hope this video helps to understand the average rate of change and how to find it for any function. I hope this video helps, and if you have any questions at all, please leave them down in the comments below, and thank you for watching.